an activity to find out what you can actually see in the cosmos, the universe beyond the Earth, and also do some research to even find out more. And the first and easiest is going to be looking at the night sky, naked eye astronomy. And so with light pollution around you, street lamps, lights from houses, you can't see quite as much, but you can see quite a lot. You will need a star chart, planisphere, which you can get online, and also to research what is visible in your part of the world, northern hemisphere, southern hemisphere, which continent you're on, which country, to get details of what is visible on a particular evening that you're looking. You might even be able to see a comet or a meteor shower. That's what you will discover. And of course, naked eye astronomy in daylight, don't look at the sun, but of course that's there in our solar system and visible at daylight. The moon is sometimes visible in daylight, and near sunrise, sunset, you can often see Venus as well. Earlier astronomers developed astrolabes for looking at the angle of the objects that you're seeing in the sky, often used for navigation but only allowed latitude to be determined, couldn't determine longitude, how far west, how far east, and needed very accurate chronometers, clocks, in order to be able to do that. And again, another way of looking at the cosmos is to consider the Earth as the center of a sphere, and you're looking at the celestial sphere, and earlier astronomers thought that all of the astronomical objects were actually on that sphere. We know they're many distances away from each other from the Earth. And here you've got a list of the rings that are there. And the Ptolemaic armillary spheres had Earth at the center. The Copernican ones put the sun at the center. But back to observing. If you've got access to some regular binoculars, here looking at 7 by 40, 7 is the magnification, 7 times, and 40 is the diameter in millimeters of the larger lens, the objective lens. And you can see the field of vision. When you're looking with your eyes, you can see a very broad amount of the sky at any one look at it. The binoculars restrict it, which is good because you're now looking at something that's magnified. Telescope has a much smaller field of vision, and it's sometimes harder to capture the object there. And you can look down the list at the objects that you can see, obviously more detail than the naked eye, and you can also look at the workings with the different lenses and prisms of one type of binocular. Then we go on to telescopes, and you're going to see even more detail, and telescopes will come with different levels of magnification, and there are 2 main types that we'll see. But you'll see a lot more detail and objects that you couldn't see with binoculars or with certainly with the naked eye. So the refractor telescope with a lens that is bending light, very large telescopes, and there are some with probably a meter or more diameter lenses. They have a problem that glass flows over a long time, and with something that has to be as accurate as a lens for focusing objects, that's obviously going to be a disadvantage. But with smaller ones, that isn't a problem. And you can see what has been discovered there. There are also reflector telescopes which have a curved magnifying mirror in them. And the telescopes that have been launched into space are going to be reflectors, and we'll see about those. First one we're looking at is Spitzer Space Telescope. It's in a heliocentric orbit, so it's going around the sun, but it's for the most part close to the Earth at the moment, and they just call it a trailing Earth orbit because it's been distorted. So 85 centimeters, 33-inch diameter, a curved mirror made of beryllium, and asking you to research what it has discovered and to reflect how much that has added to our knowledge of the universe. Spitzer was observing in the infrared region. And so, looking at the Chandra Space Telescope, observing in the X-ray region, shorter wavelengths than visible light, much shorter than infrared. And as with all space telescopes, the Earth's atmosphere is going to block any form of electromagnetic radiation or stop it being able to be useful. Obviously, the more energetic ones aren't going to be blocked hardly at all by Earth's thin layer. And again, research what Chandra has discovered, picture of black hole there, and how much more the X-ray information has contributed to our knowledge of the universe. And the last of the telescopes, space telescopes, and there are many more, the Hubble Space Telescope, observing in X-ray, visible, and infrared regions. And here the mirrors are 2.4 millimeters, 240 centimeters, and with reflecting coating of aluminum. So research what Hubble has discovered and added to our information, and reflect maybe the importance of that and its utility to us here on Earth. And you can go on to look at other space telescopes. James Webb is due to be launched in 2021.